everyone. On behalf of the IBS board, I would like to thank you all for organizing this and for joining us. And the Humboldt Talks are part of the IBS's agenda to connect the community a bit better of the biogeographers across the world. And later we'll continue with this through the Wiki Funk lectures. That will be monthly lectures with interesting speakers from all over the world. So thank you all and welcome.
Yes, so thank you everyone for attending. This session we're focusing on East African mountains, and we want to look at past, present, and future changes and challenges. And so we're going to be three of us presenting, and how we're going to do this is that I'm going to start off by giving an example of a paleoecological site that we've studied in East Africa called the Mao in Kenya. And then we're going to have our second speaker moving on to a larger site in terms of scale, because they'll be talking about the Kilimanjaro, and finally we'll have an overview. And what we're trying to do is that we want to try and present an overview of paleoecological research going on, focusing on East African mountain ecosystems, and with Kenya as our case study. So we hope that we can demonstrate that paleoecological perspectives can be useful to inform both current and future ecological and environmental challenges. So, so I will be talking about a 15,000-year record that we have from Eastern Mao Forest, and the wetland that we sampled is called Nyafuyafui Swamp. And this work was carried out as part of my PhD studies, and where the sampling was done in 2014. So this work was a big collaborative effort, and I want to thank Colin and Rob, who helped me a lot with this and are part of my co-authors for this presentation. So it's titled A 15,000-Year Environmental History Record from Eastern Mao. So when we think about past change, there are two, currently I think there are two ways of trying to reconstruct how past vegetation and past climate have changed. And we can either do this using natural archives or numerical methods. And I personally work with the natural archives, so working with wetland sediments, specifically swamps, to come up with these records of change. And the different proxies give us different signals. So, but just like every other reconstruction method, we also have a few, what do you call them, sources of uncertainty. And with wetland sediments or most of the natural archives, the uncertainty tends to come from the translation of the proxy that we get to the actual vegetation or climate signal, and the age control, which is the dating. So the goal of the research that we did was to use paleoproxies to understand the environmental history of the Mao Forest. And we had several ways of doing this. So one of the first things we wanted to do was to try and look at the modern vegetation as well as the modern pollen, to see whether we can be able, how well the modern pollen would represent the local vegetation, the local and the regional vegetation. We were also going to use different proxies, and by this I mean we were going to use pollen, charcoal, and physiochemical characteristics, so things like loss zone ignition analysis and particle size analysis, to think about things like the sand, silt, and such kind of physical features that would help us understand the physical and the geological process that are taking that are occurring in this ecosystem. And the study area that we're focusing on is called Nyafuyafui Swamp or Nyafuyafui Wetland, and it's located here where there was that arrow. So it's a wetland that covers about 122 hectares on the Kiptunga Forest block. And the Kiptunga Forest block is one of the 7 sub-blocks of the Mao Forest. And the Mao Forest is one of the 5 water towers of East Africa. And by water towers, we mean highland areas, highland forested areas that act as water catchments and so have very significant ecological and socioeconomic benefits for a wide variety of people. And through time, especially the last few decades, there's been a trend where the extensive environmental change manifested as forest loss and grassland expansion is being evidenced not just within the forest blocks, but in the catchment areas. So this photo is what the area around the wetland where we sampled. So when you look at it, so the wetland itself is an open grassland with tussocks of things like poaceae and jancaceae. But towards the edges, you can see that there's small patches of indigenous forests and woodlands. So it's the wetland itself is a small open patch, but it's located in a highly forested area. So these are just photos of fieldworks, which involves probing to see which is the best place to get our samples from, the sample collection, the sampling in the lab of the cores, and this is just when we're trying to take photos and trying to describe the records when we're in the field. So this is just the field work and the sampling process. So the aim of trying to understand the environmental history using the pollen data, the charcoal data, the physical and chemical data, and the age depth models. So sediments were sampled every 10 centimeters, and this was analyzed for pollen. We also did a high resolution sampling for charcoal. So this was every centimeter. And for the physical and chemical analysis, this we did at different resolutions. So for the particle size and loss on ignition, we did this every 5 centimeters. But for the elemental iTrax analysis, this was done at every 10 millimeters. So it was very high resolution. We also were able to collect 8 radiocarbon dates, which were age depths, which we then developed an age depth model from. So when we got the dates back and we ran them through Bacon, for the calibration, what we realized was that the base of our record was dating back to around 15,000 years before present. So that means the Nyafuyafui record is actually giving us a record of change from the late Pleistocene, the early to middle Holocene, and the late Holocene, which is actually quite a useful piece of record because there isn't any other record from the Eastern Mao or from the Mao Forest. So it forms it fills in that gap because all the other, the nearby highland ranges have paleoecological records. So this one is quite useful for filling in that gap of understanding how the vegetation has changed over time. So for those of you who know paleo work, we know this is how we end up, this is the kind of data that we end up with. And this is just to show you the diversity of the taxa that we sampled. This graph actually only shows about 21 to 22 taxa. However, from Nyafuyafui, we identified about 80 different pollen types. So that was quite a high diversity. And of course, like I said previously, so that's this is how the vegetation is changing over the last around 15,000 years. So when we run the pollen results, when we do a significant, when we try to cluster it, when we do a hierarchical constrained analysis, we find that the record actually, the pollen record shows 3 significant zones of change. The first one covers what we would call the late Pleistocene, early Holocene period. The second one covers most of the early Holocene and the beginning of up to the middle Holocene. And then the last bit, which covers the early Holocene, the late Holocene, sorry, the top. So this bottom is late Pleistocene to early Holocene. This bit is the early and middle Holocene, and then this is the late Holocene, this top bit here. So what is actually happening? Like I've said, we have different data sets, but of course, they're quite, it's not possible to display all of them at once. So the best way to show them is to have summaries where we talk about what we think are the important changes that are happening. So we have here the bottom, the late Pleistocene, the end of the late Pleistocene. And here is where we actually see the highest diversity of arboreal pollen. So this would be the Afromontane and tree taxa. And in this particular figures, the pollen groups have been summarized to ease the interpretation. However, here we have quite a high number of Afromontane and tree taxa, while the herbaceous and the poaceae cover is minimal. This diversity, and as we can see, as we move towards the top, there is an increase in the number of trees, both the Afromontane and the just the other trees. And we think the reason this was happening is that at this point we're having this increase in turnover in biodiversity is because there's a change in the ecosystem. So there's a turnover where we're having this ecosystem first being dominated by cordon and cordia, croton, ficus, and juniperus, and then it becomes dominated by things like Apodytes and Celtis, Dracaena. So, which is signifying that there's a turnover from a cooler, drier environment to a warmer, wetter environment. There is also quite a bit of charcoal concentration here. So this is pieces per centimeter cubed. So this is quite a high charcoal concentration here, and we think this is natural burning. And when you look at it in together with the other pollen record that actually shows that different taxa, we see that there's a relationship between the charcoal concentration and the Juniperus and Hagenia species, because the Juniperus is a pioneer species which tends to occur after there's a fire. The next zone is the middle bit. So this bit is we have both. So we start with the early the early Holocene, a bit of the middle Holocene before we go into the late Holocene. And what we are seeing here is that there is the Afromontane taxa are slowly decreasing, while there's an increase in the herbaceous and poaceae taxa, implying that the environment is opening up a bit. So there's a change where there's an increase in temperature, and this implies that it's a relatively warm and dry period. And at the same time, we can see that the charcoal concentration has several peaks, which also peak with the organic matter. The the lithology in this section compared to the bottom section is quite similar in terms of there doesn't seem to be much reworking of the sediment compared to the bottom, which was highly stratified or laminated. Actually, that laminated is the right word to use. Finally, we've got the top, which is the late Holocene. And at this point, we can see that the Afromontane taxa have completely, when you compare it to the rest of the period, there's quite fewer Afromontane taxa, while the poaceae has increased compared to the previous zone, and the herbaceous taxa seems to have also decreased. This is also a signal of that there the aridity, the aridity is continuing. And at the same time, this the reduction in Afromontane taxa is way more is way higher than is expected than what would be from just a natural signal. So at this point, we're starting to think that we have targeted removal of Afromontane species, which have a high value, both first opening up the environment for land use, and mainly for sort of extraction of timber for industry outside of the forest, which has been seen, which has been shown to have an impact on the lowlands. So the increased land cover change, where we're seeing a loss, or rather a reduction in Afromontane and tree cover with combined with an increase in the Poaceae and the herbaceous taxa, is having an ecological impact on the lowlands, on the catchment of the Nyafuyafu wetland, or of the Mao Forest. And this is seen in the different catchments. So we have one of the catchments is known as the Sondu River catchment, and the other one would be the Mara River catchment. And there's been studies that have been looking at the impacts of have been looking at this socio-economic but also ecological changes in these lowland areas. And what they're finding is that they are describing that changes in the highlands, so land use change or land cover change, that is driving loss of forests to so reduction in forest cover, which is accompanied by an increase in cropland cover, or reduction in forest cover, which is accompanied by an increase into grassland cover, is causing ecosystem changes such as increased sedimentation and erosion down the rivers. And in areas where the main rivers are used as sources of hydroelectric powers, it's then causing, it's disrupting the planning ability, because these industries that rely on regular amounts of water flowing from the Mao have seen a reduction in the water flow. So the recent increase has been attributed to occupation of this highland ecosystem by communities that have moved there because of being displaced from other places in the country, and they have contributed to ecosystem disruption by logging and charcoal burning, which have become the primary economic activities within the Mao Forest. So what we're hoping is that these studies, where we show that the different proxies give us different signals of change through time, are showing us that the changes that are occurring are having a significant impact, not just within the mountain ecosystem, but in the different catchment areas. And if despite the fact that there are places that, despite the fact that there's a lot of forest loss, in areas where we're having activities, restoration activities, or where things like agroforestry or tree planting are being encouraged, we are seeing places where we're seeing that there is a reversal in the trend of where you have grassland that's reverting back to forest land. And also the fact that then you also see a reduction in the amount of soil erosion that is occurring. So even though there's quite this change that we are seeing, this a very high rate of deforestation that's occurring, especially within the last 100 years, it is possible to be able to deal with the ecological fallout from it. But we need different kind of studies, both up in the forest ecosystems, but in the different catchments areas, to be able to understand what would be the best ways to deal with the impacts that are observed. So I would like to thank the people who helped us with the field work. And these are from the National Museums of Kenya and the British Institute in East Africa. Thank you.
Thank you very much, Esther. And I forgot to ask whether you wanted to do your Q&A question period right after your talk or to wait after all the talks. Do you have a preference? Or we can do both.
Yeah, if there's a specific question, I can answer it now or wait until if, okay.
There's one question now from George Stevens, who says the transition between the earliest period and the middle period appears to be very abrupt. Are there any clues from other sites? What may have caused this abrupt change?
Yes, well, actually, that's a very good question. And I have to say, I think I should have used a better transition line, because the changes, and it's not just a complete switch, it tends to be gradual. So in some sites, you might actually experience an abrupt change, but in general, it actually is more of a transition period. So I think it would have been better if I had showed maybe a gray shaded area instead of a straight red line, because it's just never that one to the other. And I can, if he's interested, I can find examples for him that show places that have experienced it gradually, and if places that have experienced it abruptly. But at Nyafuyafui, it's more of a gradual change.
Thanks. And for everybody who wasn't here for the first slide, you have the ability to ask questions in a couple different ways. There is a chat box that you can enter questions in. There is a Q&A box that you can ask questions in, and there is also the ability to raise your hand with a little hand icon along the bottom, and we will unmute you. Or you can just ask to be unmuted as well. So I think sometimes it's easier to ask questions verbally, and depending on your typing speed. So if there's no more questions right now, we can move on to Rahab's talk. Thank you very much, Esther.
Okay, good morning, good afternoon. Depending on your time zone, I am in my afternoon, so I hope everybody can hear me. I'm Rahab Kinyanjui from National Museums of Kenya, and I'm going to talk about, let me share my screen now. Share. Okay, I'll be talking about human-environment interactions on the Kenyan Highlands, past, present, and future opportunities and related challenges. And I'll just give a quick overview, at least a bit of the background of the human-environment interaction in East Africa, which dates back to at least 2.4 million years. And these interactions, they've been believed to have played a critical role in shaping the human evolution trajectory and basically the migration of from Africa to Europe. And during mid-Pleistocene, East Africa experienced rapid climatic variability. And we have a lot of evidence from archaeological record that shows how humans were able to seek refuge in highlands during extreme dry climates, especially when it was very dry. Also, research has suggested that human impact on East African landscape was mainly noticed in the recent times when the introduction of crop farming happened. Around 2,500 years ago. Unfortunately, very little evidence is left behind by the pastoralists. So most of the time, the nature of evidence that we have it's quite spotty. And for the crop farmers who are mostly in the highlands, because of the preservation issues, we still have, again, a limitation of getting data that has been preserved quite well in the mountains. In the Holocene period in East Africa, the climate varied greatly, having a wet humid period around 12 to 10,000 years ago. And then we had an arid time during mid-Holocene, when actually we had the introduction of pastoralism. We have the evidence in northern Kenya, the Turkana Basin. And this forced the communities, the Holocene community, to shift from the economic subsistence from fishing, hunting, and gathering to pastoralism, depending on the resources that were available in the basin. And then in the Anthropocene period, we see again human interaction, environment interaction is becoming more complex because of increased populations, intense industrialization, having to move from local-based to global-based kind of communication and interactions, technological innovations, and unpredictable climatic changes that are happening in the recent time. Most of this evidence, however, has been found in lowland and arid regions where at least the preservation is quite, it has less challenging, other than in highlands. So what what I'm going to present today, I'll talk about the Kilimanjaro. We just did some research there, recently published, together with Mustafa Colin and other of my colleagues. And I'll present a proposed why we are having this research became a baseline of some work we have proposed to work in Aberdare Ranges in some of the forests. And Kilimanjaro is, as many people would know, it's the highest mountain in Africa. Geologically, it's a dormant stratovolcano, and the evidence of human influence goes back to around 745 years before present, at least what is culturally recorded, currently recorded. And the people living in around Kilimanjaro, why being Kenyan, I'm presenting this work as part of Kenya, is politically and geographically, Kilimanjaro is in Tanzania. But when we come to communities, interactions, and exploitation of the resources in Kilimanjaro, there is no much caring about the borderlines. So the vegetation varies from the peak, the bare glaciers in the highest points, all the way to semi-arid savannas on the lowlands. And in the Kenyan side, it's the Amboseli Basin. And then we have forest glades that have been used for a long time by the pastoralists during the dry season. And agricultural activities around the mountain goes up to 1,700 meters above sea level. And most of the crops that they are cultivated, and this mostly in the southern part of the Kilimanjaro, it's wheat, bananas, millet, coffee, cotton, wool, and maize. When the historical and archaeological evidence of what has been there in terms of human impact and human in living around the mountains, we have during mid-Holocene, they were doing hunting and gathering, which was followed by pastoralism in around 4,000 years, and recent the agriculture. At the moment, from the work we did recently, we have no direct proxies that show the human occupation in the high elevations, but we have charcoal data that suggests human-induced fires regimes in this high elevation in the core that we had that dates back to 3,000 years. I'll talk about in the following slides. Then we look at the human activities and how they have changed over the time. Initially, it was hunting and gathering, then pastoralism and iron smelting, which was also coupled with the agriculture and crop farming. Then we have, in the recent time, where we have intensive agriculture going on at the baseline of the Kilimanjaro, livestock keeping, honey harvesting, tourism, logging, and tree plantation, which are kind of forcing, having pressure on the forest. And the picture you see there is some of the tools that have been found there from Kilimanjaro. And this was found by Robert Marchant, who is in this forum, and to show its evidence that people were actually living around and exploiting the mountain. So what we did in the recent paper is that there was multiploxy analysis, where we analyzed pollen, phytoliths, and charcoal, and constrained with the radiocarbon dating, which shows vegetation cover has been changing rapidly within since 3,000 years, and in high elevation, where the Ericacea belt is expanding rapidly. And as we link this to human-induced fire regimes coupled with the drying climate. I'll draw your attention to, just like what Esther had presented earlier, about the tilia diagram, the pollen diagram. And you can see the charcoal, draw the charcoal intensity. It's much on the upper part of the core. And then we have the Ericacea pollen that showed a lot of dominancy. It dominated within that around that times from 500, 600 years back. Whereas we see it was quite few before then. Things like Stevie also, it's coming up, and these are mostly associated with the fire. They regenerate quite fast during fire, the after fire regime. Then our phytolith record did not give really much specific information on this, but we can see how the forest indicators and the dicots are generally quite many. And I'll call attention to the spheres, which are mainly directly derived from the woodlands. And we see the forest had kind of decreasing. The morphotypes are decreasing towards recent time, showing at the same time when the fire from the other diagram is high. Also, I'll call upon the chloridoid grasses. We see these are C4 grasses, very short C4 grasses that do well in arid or dry climates, and they are indicators of aridity. In the below, in around 3,000 to 1,500, we see the chloridoid grasses were quite few, but we see now them coming up in the upper part of the core. Aristide also, they are also good indicators of very shallow soils and disturbed grounds. And we can see from the core, they were actually coming up in the upper part of the core. Oh, this should have come earlier about the age model that was used to constrain our data. So based on that, because we have very little, not much information on what is happening in the mountains and the human impacts directly, we are working to try and fill in, work on many sites. That this was the recommendation of our research, to try and work in many sites so that we can be able to fill the gaps, both temporary through time and across space, so that we can know exactly what has been happening in East Africa and what are the roles of the mountain in East African dynamics. So we have a proposal that we submitted to British Ecological Society that we want to work in the central Kenyan Highlands, Aberdare Ranges. Again, we propose to use palaeoecological proxies, the same proxies that we worked on in Kilimanjaro. And the questions that we need to understand, we want to look at the recent time when the population has already increased in East Africa, and the role of different governance and different policies on the landscape. So we want to use paleoecological proxies to reconstruct this vegetation dynamics in the last 100 years and see the preservation of both natural and cultural remains in the moist forest, what is being lost, what is not lost. And we have to also collect data from all literature. The main objective is to identify and map occupation caps in the Greater Forest, because it has been used by the community around these areas before the colonialism. They used to live in villages, and they would do communal farmlands within the forest, especially on the grass glades. But after, when the colonialists came in, they were pushed away from the highlands so that the white men can start the agriculture. So we are to excavate the sites that we will identify and see the cultural and natural evidence of human occupation, then collect sediments from areas that are known to have been occupied versus those that are virgin, that have never been occupied, and analyze for plants microfossils and see how these change, whether we get a signal from the paleoecological proxies, whether it will be able to tell the story within a very short time. Then we also propose to analyze macro and micro chapter to determine the fire and the impacts of fire, and what kind of fires are they, local or are they human induced, or what are the main drivers of the fires. And then to study and document this and correlate the vegetation data derived from plants microfossils. So the expected research output from our work will be used to provide scientific facts on the importance of conservation. Currently, what is happening in Kenya, there are still people who are living in the highlands. They are still exploiting and doing farming there. And the forests, we're not sure how much of diversity is being lost by this kind of settlement in the forest. And the government is drawing policies that people should be evicted from the forest, but they do not have like long-term, not long-term like to back to the Pleistocene, but long-term data to show how how people have impacted the forest, and to convince people the reason why they should leave forest for conservation, for future, and for other, for balancing our ecosystem. Okay, I think I'm done. God.
Thank you very much, Rahab. It was a great talk.
Thank you.
And I am pretty inexperienced at Q&A periods, so apologies for missing George's last question. Second question, does anyone have any questions for Rahab? And she's not showing her video right now because her internet connection is sometimes tricky.
Yes, I apologize for that, because my internet is phone-based, and sometimes when I do video, it gives, so just to be sure I present my work, I can set my photo in the process by the time Rob finishes.
So while I'm checking the various spots for questions, I'm wondering if it's, given this is your aim is, or sorry, the conservation aim, it must be quite challenging to ask to evict people from places they've been living for a while. What's your experience with that? Do you have to deal with that end of things, or is that more as a policy to inform policy?
Yes, personally, I don't have to deal with that, and even my institution doesn't have to deal with that. Ours is to provide hard data and to illustrate these dynamics, and for the people to understand the relevance of conserving the forest and conserving these places where we have indigenous forest and the indigenous ecosystem, so that we can save this for the future generation, and also we can save it for what is happening in the whole ecosystem dynamics and the climate change scenarios. Because many people now are suffering with the flooding that's happening when we have more rain. There's a lot of flooding because the erosion is taking place. There's no, the ground cover has changed a lot over the time. So us is to try and provide hard evidence to show that if people can switch from using the forest, it is recoverable. You know, like many people believe that probably it's irreversible. But now the Aberdare work is, we hope it's going to illustrate that, because it has been occupied before colonialism. Then during colonialism, people were evicted from the forest, and they were living in the villages neighboring now the forest and the highlands. And since then, they've never been taken back. Although when we got the African government, they introduced Shaba system. I'm going to explain what this means, where people are allowed not to stay in the forest, but they can farm in the forest. And the foresters or the government would plant 3 seedlings, both for logging, timber logging, and also for indigenous restoration. And they will take care of these seedlings until they get to a certain height. And once they achieve maybe 1 to 1.5 meter, they will stop the farming practices in the forest and leave that as a forest. So it was like a gradual way of removing people from directly exploiting the forest. And it has worked now with the Aberdares, and we want to use now the data from Aberdares and see whether it can be applied in Mao, which is currently the huge and the hot debate on evicting people from Mao Forest. So this will be used as an example. We hope so.
Sandra and Miguel, have I missed any questions anywhere? Okay, so thank you again very much, Rahab.
You're welcome, thank you.
So Rob, you are up. Thank you.
Okay, so it's really nice to be part of this event, and as Rahab said, good morning, good afternoon, good evening, wherever you may be. So it's been really nice to hear the presentation from Esther and Rahab talk about some specific sites. I'm going to talk a little bit more broadly about work we've been involved in, I guess, across the East African region over the last couple of decades. And I guess this provides a nice sort of schematic for the talk, because yes, we're going to be looking at the past, but we're also going to be looking into the future, and show how some of our sort of paleoecological insights have led into and underpinned some of the sort of more sort of future focused tools that we use to try and understand some of those things that Karen just talked about and Rahab responded to, around rapid land cover change, forest conservation, and understanding the interactions between forest and land cover changes and ecosystem resources. And we've already seen from Rahab and Esther about a couple of very nice locations, one from sort of Kilimanjaro down here on the Kenya-Tanzania borderland, another one from up in sort of Mao area up here. And these are all locations that we've worked on over the last couple of decades. And as those sort of dots across the landscape, from mangroves to the high altitudinal sites such as 4,000 meters on Kilimanjaro that Rahab's just been talking about, lots of montane locations, also quite a few increasing sort of savanna sites, as they all start to come together, it allows us almost like a, one of these sort of dot-to-dot pictures to join up the dots across the landscape and understand broader scale ecosystem change and what's driving those changes: climate, human, atmospheric, fire interactions. And I'll sort of show you a couple of those from a couple of sites we haven't talked about so far, and then go on to the future focusing tools. So just next to Mao, that Esther talked about, we have Mount Kenya. It's been quite a focus of sort of paleoecological work for the last 20 to 30 years. Some excellent records produced by people like Dan Alago, Elaine Street-Perot, Matt Wooler, to name but a few. And it has this sort of typical concentration as you move up the mountain through various montane forest types into ericaceous vegetation. And then once you get up to around about 4,000 or so meters, moving above the forest line into a sort of tundra type environment. And there are still little bits of permanent ice clinging on. At the other end of the altitudinal spectrum, you've got very, very steep gradients. Literally from 1 meter to the next, you go from very densely populated, intensively farmed land into a national park. And obviously that protection is maintaining those forests under, increasing challenges as populations grow, as climates change, and yes, the government is trying, but obviously challenged by some of the enormity of these changes. So the types of records we can produce from these swamps go back, in some cases, 40, 50,000 years. This is a good example of the changes from one site. It's a really nice site, about 15 meters of sediment. And this just zooms in those sort of late glacial transitions as you come through the last glacial maximum through into sort of the late Pleistocene. And we can see that the fire regimes change very dramatically as we move through the last glacial maximum. And that change in fire regime is mirrored by changes in individual taxa, as well as the broader sort of montane forest ericaceous interaction. And, one of our challenges, I guess, is as paleoecologists is trying to portray these changes in more accessible ways than our traditional pollen diagrams. And we do that through these types of cartoons where we can see changes in ecosystem composition and some of the drivers behind that change. Changes in our core insight as it transitioned from a lake to a lake surrounded by a mire to a mire, as cultivation spread into that park and formed that very, very distinct gradient from cultivated to non-cultivated land. Another location now just to the south of Kenya, so it's Kilimanjaro, what we were talking about earlier on. This is a record that Gemma Finch produced a few years ago from the Pare Mountain. So this is one of the sort of mountain blocks of the so-called Eastern Arc Mountains of Tanzania, probably one of the hottest of the global biodiversity hotspots. And we'll be looking at this at the past, but also in terms of some of the future changes that have gone on. Similarly, we produce a sort of summary record of the transitions. In this case, it's quite recent. It's only the last, I say only, but we have a nice record that goes back about sort of 1,300 or so years. And again, we can really look at the impacts of those historical changes on the landscape, particularly in terms of fire behavior. So we can see fires becoming particularly important from around about 1300 AD, but nothing compared to the transitions that took place in the 1800s. And obviously that's mirrored by this massive rise in our anthropogenic indicators, our disturbance indicators, decline in timber trees, valuable timber trees. And that, again, as Rahab was talking about, really driven by those early colonial sort of pioneers or exploiters of the landscape, as they moved in and replaced valuable timber trees, indigenous timber trees, with things like pine and eucalyptus, and obviously changed that fire regime. Also, a driver of that change was the, well, twofold. One, the arrival of exotic crops, maize coming in from the so-called New World, Latin America, Central America, brought in by the Portuguese. And one of the reasons why that was brought in was largely to fuel what we now know is the ivory trade. So as new crops arrived, it allowed large caravan trades to be, trains to be fueled, to be fed. And these would be sort of thousands of people strong going in from the coast of East Africa into the interior, and basically decimating the ivory, the elephant populations, exploiting the ivory, causing landscape transformations as they went. Our last site, and again, this is something which is very interesting for us at the moment, are these the sort of highland to lowland transitions. Esther was talking about Mao. That's a catchment headwater for the Mara rivers that flows through Masai Mara, Serengeti, famous for the large wildebeest crossings and things. And again, as those mountain systems change, then of course those lowland environments will also change. Likewise, another national park just to the north of Kilimanjaro is the Amboseli National Park, characterized by pastoral communities and these large swamps inside the protected area and outside the protected area. So again, just clearly showing the impact that that present day national park system has. These provide our sort of paleoecological archives and sort of some sites that Esther, amongst others, worked on a couple of years ago. Again, trying to move away from those pollen diagrams, we can see massive transformations within those sites as we go through the last 4,000 to 5,000 years, as the vegetation changed, as the swamp itself became a lake, and then eventually a lake with a sweet fringing swamp, as fires change within the catchments, as increasingly the Shamba system that Rahab was talking about starts to come into force. So looking across the East African landscape, one of the things we've been doing is compiling these data. And I say, as we start to pull these individual dots on the landscape together, we can really get a good sort of temporal spatial view of change, particularly when we combine with the archaeology, as Rahab was showing through some of the sites on Kilimanjaro and the surrounding areas. And particularly looking at large-scale land use transformations, which arguably has probably been a bigger driver of ecosystem change than climate, certainly over the last 6,000 years. So we move from essentially a hunter-gatherer, forager population. Around about 3,500, 4,000 years ago, we start to get this sort of quite rapid spread of pastoralism, particularly coming in from the sort of Nile Valley. As Egypt started to collapse, a lot of that sort of pastoralism spread into East Africa. Around about 2,000 years ago, we start to get the early signs of agriculture, but that spread very, very rapidly, as indeed has pastoralism continued today. And today we have this sort of mixture of agricultural, pastoral societies. And certainly in the more recent decades, last sort of 50 or so years, a lot of those sort of pastoral communities are increasingly becoming more sedentary, transitioning into agriculture. And that again causes and brings with it sort of management and conservation challenges as we sort of see that continued spread through to the present day. Okay, so what do we know from our paleo records? We know clearly ecosystems are incredibly dynamic. They change as a result of climate changes, fluctuations going back through to sort of glacial, interglacial cycles, but also more recently through the Holocene, large-scale climate changes, often mediated through fires, changes in atmospheric carbon dioxide. Animals are crucially important, either as cattle and sheep and goats arrived on the landscape and became more numerous, or indeed other more numerous animals like elephants were removed from the landscape. And this, just to show how important the interaction between fire and animals are. I have a sort of paired couple of pictures here, actually from Southern Africa. But this is a view from the 1940s from Kruger National Park. And this is a view of the present day. As fire regimes have become less intense, as animals have been moved outside of the protected area, and as carbon dioxide levels have grown, we see this increasing spread of savanna across many areas. And that has significant implications for ecosystem management. And of course, that's about managing the future. Okay, so that segues into the future. So we're going to talk very briefly about two tools. One is a sort of a generalized additive model, which we developed to look at species distribution, quite analogous to like a niche type model, but it adds up all the various drivers behind a niche. And for each individual taxa, we can look at its niche across the landscape. So here's for one sort of Mycene Monophyllophiles and montane forest tree. Here are those Eastern Arc Mountains that we talked about earlier on. This is sort of the Aberdares and Mount Kenya up here. Our models are very much based on collaborations with people in national museums, sort of herbaria around the world, and local botanists, and indeed our own botanists have then gone out and ground truth these models. So this is another species up in the Pare Mountains where we have that paleo record from, looking to try and find a large 40-meter high pea, so a legume member of the pea family. Montane forest tree, not found in the lowlands, not found in the highlands, in that sort of montane distribution. And what we can do then is pull all of those niches together. So this is for 570 tree taxa of the Eastern Arc Mountains, this biodiversity hotspot where we had our paleoecological record, that we know has been severely impacted. And indeed, this grey area is the sort of so-called paleoecological extent. That's the natural extent of the forest. And that's all converted. The colour is where there is existing forest, and that is continuing to be nibbled away. But then within that, we can see where the degrees of endemism and the degrees of species richness are highest, and they tend to be on those eastern flanks, so facing the eastern, the Indian Ocean, moist winds that come in off the warm ocean. One of the things we've been able to do from the paleo records is take a series of cores across this Eastern Arc Mountains and look at issues around stability and change, and that's a whole other story. But indeed, you know, we do see that this incredible storehouse of biodiversity has been relatively resilient to changes in the past. Some of the modelling that we've been doing suggests that it will be resilient in the future. But of course, that's within certain boundaries, and it's only so far that you can push these ecosystems. But we can look into the future, so we can substitute our present day climates for future climates and look at individual taxa, such as, so just two examples out of hundreds that I could have chosen. This is a tree which is quite an important medicinal plant, Prunus africana, montane forest tree. Across East Africa, it's projected to lose habitat as we go into the future. Other trees, this time Kea anthotheca is an important tree, often found around shambas, villages, woodlots, is projected to increase. So again, always going to be winners and losers from future climate. One of the things we have been doing over particularly the last 4 to 5 years is developing much more participatory tools to try and understand what the future will bring. So lots of sitting, and I think that's actually Esther there, a bit blurry, but talking to people sitting under many trees across the landscape, trying to understand some of the challenges and what those future challenges may be, using a participatory scenario modeling tool we developed called Keisho. A literal translation means tomorrow or later. And effectively what we do through a whole series of workshops, and we've run now about 20 of these across different landscapes, each with about 20 to 30 people in, is to try and understand how the environment and the economy is changing into the future and what's driving that. And we tend to focus on 2030 and 2063, so a near-term future and a more distant future. And we can then translate our perspectives in terms of land cover change. We can then look at those land cover changes in terms of things like carbon. So this sort of talks to some of those issues around reduced emissions from deforestation and degradation, some of the sort of climate change treaties, and look at how that carbon stock could change, under a business as usual, so continued use of forest resources, continued nibbling away of the forest, continued conversion for agriculture, versus a green economy where there is effective management, there's effective legislation to stop that, reserve boundaries are respected. And one of the things we've been doing then is taking those maps and then looking at interactions with other resources like water and biodiversity. So we can then produce the even more complicated maps, such as this. So this is Tanzania, looking at interactions and changes in biodiversity, in water and carbon all together. And we can start to see where there's going to be particularly high impacts on carbon and biodiversity. So this is up in those Pare Mountains where we have our long-term records from. We can look at areas where there's going to be particular high impacts in water over towards Lake Victoria. We can look at areas where there's going to be high impacts on all of dimensions. So biodiversity is going to be heavily impacted. Water is going to be impacted. Carbon is going to be impacted, even under our green economy future. So even under the brightest future that we can envisage for that particular mountain block of Tanzania, there are going to be massive challenges. So this starts to allow us to think about priorities for management. We can then zoom into certain locations. So this is another project where we were looking at sort of coffee farmers up in Ethiopia. As part of many, many mountains that we were looking at. I just pull this out as one example, the last example I'm going to show, to look at how coffee farming could change into the future. So this is our present day landscape. This is our sort of business as usual. This is a sort of industrial coffee landscape, so where we have more coffee plantations. And this is a sort of more agroforestry, high value for sort of frog friendly, butterfly friendly, biodiversity friendly coffee, where there is more sort of semi-managed natural coffee forests. So there's gains for biodiversity, gains for carbon, and hopefully obviously gains for coffee farmers, but obviously that comes at a price hopefully picked up by the consumer. Okay, so just the last slide, hopefully leading into a discussion. So what we've been able to do is really sort of understand those changes, spatial, temporal directions of change, understand ecosystem dynamics at a range of different scales, from individual species to communities to different ecosystem types, functional groupings. Try to understand those interactions between ecological change, social change, hydrology, biodiversity, carbon, livelihoods. Look at changes in non-climatic factors, particularly land use, social change, crop choice, another thing. And at the heart of a lot of our work is really around trying to use these insights to inform sort of management choices. So ultimately, you know, those forests can be preserved, they can continue to function, they can still feed waters that will flow and contribute to downstream communities. And that, I think, is where I'd like to leave it. Thank you.
Thanks very much, Rob. I'm going to turn things over to Esther now for the question session. In the meantime, I'm going to let attendees know, just because it's easier to ask questions live sometimes, I'm going to unmute everybody now that all the talks are done, but you can still use either the chat or the Q&A or raise hand options. So it'll take me a few moments to unmute everybody.
Thank you very much, Karen.
Yep, thank you, Rob. Thank you, Rahab. Your talks were very comprehensive. I'm sorry that I got a bit tongue-tied when I was presenting, but I hope at least you were able to follow what I was also talking about. So that's the sort of work we've been involved in East Africa. Those are the different sites. Those are the different techniques that we're using. And if anyone has any questions, please feel free to ask. If you're also working there, and you can also let us know what you're doing.
Yeah, so I saw a question from Suzette.
Yes.
So yes, in one of our challenges can be try and get equal participation of men and women into the workshops. Often when we run the workshops, we will say engage an NGO or a government department or a community-based organization, and they will select somebody to come to our workshops. So often we don't have that much control on who actually turns up. And often, unfortunately, there are often biases in attendees. And we've been actively working to try and sort of remedy that, often in terms of how we run the workshop. So, for example, we ran through a project we have called Adaptation and Resilience to Climate Change, looking at sort of pastoral conservation issues. We ran 4 workshops across the sort of Serengeti and Amboseli region, and they were led by a lady called Rebecca Karaoke, and she had sort of separate workshops for men and women, or separate spaces within the workshops for men and women. So again, voices could come through. Again, we try to encourage somehow sort of equal participation, but certainly in our first iteration of workshops, yes, there were biases, and that's something which we continue to try and address.
Great, thank you.
So if there are any other questions.
Well, I would have another question. I was wondering, so you were talking about the different ecosystem dynamics and the shifts between, you know, how the mosaic pattern of the landscape, you know, of course it changes through time. So I was wondering how dynamic you see the change between different types of forest or shrublands, and if there's also, you know, this pattern of maybe used lands being recovered again, or is it just one pattern of constantly conversion of natural to anthropogene and it stays like that, or is there a turnover also, like among different types of land uses and natural systems?
I'll start, and then Esther or Rahab can come in. So in short, it's location context. It's not unidirectional. I mean, one of the nice things we did on another project we had called Historical Ecologies of East African Landscapes is that we had somebody go into those early photographic archives and doing sort of repeat photography today. So often spanning maybe 100 or so years, also digitizing early explorer maps and accounts, and then revisiting those locations in the present day. And you know, we see, for example, a lot of these landscapes had many more trees in, say, in 1910. Or sorry, many less trees than they do today in 1910. Other locations have, you know, as I showed from Kruger, that's quite a common picture across East Africa, where we go to, say, Laikipia, the savanna areas, many more trees in the landscape than they did. So some areas are gaining trees, other areas are losing trees. One thing that we do find, if we just focus on the mountains, that sort of loss of mountain forest has been continual across all mountains. You know, be it Kilimanjaro or Mount Kenya or Marsabit or wherever, they've all lost massively. Initially through colonial exploitation, and then subsequently through, you know, ineffective government policies, ineffective institutions. Yeah, unfortunately, mountains are nice places where people like to live. The soils are fertile, the climates are quite temperate, diseases are less, things grow very well, and you know, that leads to forest conversion and agricultural expansion. But yeah, it's certainly not unidirectional. It's not one case fits all. So it's very context specific, and I think that's why you need to have lots of those little dots across the landscape to be able to piece them together. I don't know if Esther or Rahab would like to add.
Yeah, what I can say, just like what Rob has said, it's not unidirectional, and then it varies from one location to another depending on what people are doing and how well equipped people are in terms of technological innovations and the needs, how people are using these lands. So you realize there's some people who are, when they are cropping, they have a monocropping in an area, and that becomes even worse case scenario because they have one way of clearing forest just to have one kind of product, one kind of crop. Others, they do mixed cropping, which is more or less advantageous. And again, it also depends on, are they bordering conservation areas like national parks or just forests, because the policies of the forest department and the policies of the Kenya Wildlife Service policies, they are not similar. So it is quite complicated and it varies from one site to another. But, and I also, like, when it comes to research, to give scientific hard data, the government of Kenya, for instance, it's not one of the priority to fund for people to understand these dynamics and the impacts and what is happening. Whereas maybe somewhere like in South Africa, the government is willing to chip in and see where they can bring money to have science data to see what the facts, factual data to be able to advise and inform the policymakers. So it's kind of complicated. You can't say, you don't have one answer for one side. It's different.
To add on to that, there's also, so I'll give an example of Mao Forest, where until very recently, let's say about 200 or 300 years ago, you see it's a forest, but it's a different kind of forest through time. So one of the things that we're thinking about, and not just for Mao, but other mountain sites that we're able to get data for, is to use the biomission approach, where we'll be looking at trying to turn our pollen data into PFTs and then biomes, and seeing if that will help us understand the changes at a higher resolution, and to see whether they're actually fluctuating within, for example, a time period. For example, within the early Holocene, is it all one type of forest, or is it fluctuating between different times? And can we relate that to what we think might be happening with the climate? So even within a single study, it depends on what temporal resolution you're looking at. However, I think we'll be able to answer some of these questions, I think, better with more research, and we'll soon be trying that biomission approach. I think it's going to be quite useful as a way of helping us understand our pollen data as other than just as pollen data, but looking at it as changes in biomes at specific temporal times, and comparing that between sites so that we can see whether our changes are agreeing between sites, and whether what we see is a regional signal or a local signal. There's a question from Olivia about the study. And so for the study that focuses on Mao, unfortunately, the Nyafuyafui wetland is the only swamp that has been, we did a bit of survey, and that's the swamp that we found. And so it would be good to go back. I'm sure if you do a bit more survey, you'll find a few other sites that you can probably call. But this one was at around 3,000 meters above sea level. And so I would say for that question, yes, it's the only site that we have from there. So it's the only site that's currently representing the Mao Forest. And Rob, there's a question for you about reforestation efforts.
Yeah, so again, just on that last question, I mean, yes, it's the only site from Mao, but there are sites from nearby. And I know Rahab has just got a new project that's about to do some more work on the Aberdares, which is about, about maybe 50 kilometers away as the crow flies, I guess. So it's not too far away. But yeah, we still have relatively few sites across the landscape. I mean, I say we probably have around about 100 or so locations. If you go to, say, North America or UK, you've got thousands and thousands. So we still have a long way to go to catch up, but we're getting there.
Awesome, thank you.
There was the question about the reforestation efforts. Yeah, I think it's vitally important. I mean, I guess a lot of people are aware there's lots of initiatives around reforesting not just East Africa or Kenya, but Africa, as part of the Bond Challenge, and 100 million hectares of areas planned for reforestation as part of the climate change battle. And it's incredibly important, but it's incredibly important to reforest right, and to manage the existing forests, which are incredibly degraded, to try and maximize forest regrowth and the indigenous growth of indigenous species. And we're doing some sort of ecological restoration work on the Usambara Mountains and the Uzungwa Mountains with Andy Marshall, looking at sort of liana thinning and how that impacts on, say, forest restoration. So yeah, and forest regrowth is incredibly possible. I mean, we've been working with one organization called TIST, a sort of small, locally based community-based organization around trees on farm and tree growth around Mount Kenya. And that's been incredibly effective. And you can go and type in TIST to any sort of Google engine or something like that, and you'll see like a little movie of afforestation spread across the sort of Mount Kenya region. So yeah, reforestation can work. It can be very effective. Can be a very good way of enhancing livelihoods. But obviously it has to be done correctly, and certainly not, with eucalyptus and pine in the bad old ways.
I just have a quick question, if possible. In regards to the surrounding wildlife in the Mount Kilimanjaro region, have you guys seen any effect on what you're studying and in your data collection? Have they come into contact with any of the sites that the fieldwork is being done on, or any correlating studies that would help advantage your research at all?
With wildlife specifically?
Mm-hmm.
Yeah, so we presented one of the sites from sort of Amboseli, which is obviously a lowland area just to the north of Kilimanjaro, about 40, 50 miles away. And there we've had, there's massive impacts on wildlife. And part of it is through this historical trade in wildlife. Today we have around about 200,000 elephants across East Africa. We don't know how many there could be, what the carrying capacity could be, but certainly I've seen figures of 20 million bandied around. And if you look at how the height of the ivory trade in the 1850s, probably around about 200,000 tusks were removed every year to the US, to Europe. So there was, industrial scale removal of ivory, and that's continued through poaching and things today. And, there are ongoing and other threats and challenges to wildlife, the agricultural transitions we've talked about, but also the big infrastructure changes. And one of our other projects is called the Development Corridor Partnership, looking at the impacts of new railways and road systems and pipelines that are coming across East Africa. Mm-hmm. And that has a big impact on wildlife. You can take, and there's lots of good data, particularly since the 1950s. And one of the things I think where the paleo work and the archaeological work helps is to provide that sort of pre-1950 or pre-colonial sort of context, which is really sorely needed. But certainly, there's been massive changes across Serengeti. Wildebeest numbers have gone from 50,000 in the 1950s to over 1.5 million today.
Wow.
So massive transformations on wildlife, and a lot of that's driven by protected areas, agriculture. So massive transformations on wildlife.
Great, thank you.
Yeah.
Thank you, Rob. Another good example is still from the Amboseli, is that if you think about all our field visits, we sometimes have to talk to the locals, and they have to advise us when you can go to a particular area, because we know that's when the elephants will be there, or that's when the hippos will be there. So we know the assumption is that there's probably been more animals in the past than there have been now. So if we're still interacting with them now, it shows that we're definitely impacting on them we have to now share the space in a more closely related way. But it's quite exciting to work in those landscapes.
Yeah, sometimes a bit too exciting.
Yes. Yep.
Well, a huge thank you to all of you, Esther and Rahab and Rob. It's been lovely to have you as speakers. I think I've checked all the spaces for questions, but if anybody has last minute questions, ask now. Otherwise, thank you again. And
thank you.
We hope to see you guys in the future.
See you soon. Good luck with the rest of the session.
Thank you. And thank you, everybody, for attending.
Yes, thank you very much for attending.
Bye.
Bye.